Tutorial sheet number 9. Integrate the following functions with respect to x. So we have question number 1, which is 4 over x3 minus 1 over x squared minus x squared. I want us to integrate this. So in order for us to do the integration on that question, as you are seeing, the variable that is there is x. So it will just be the integral 4 over x3 minus 1 over x squared minus x squared dx. Then this we can just take it on top. 4x to the power negative 3 minus x negative 2 minus x squared dx. So I'm sure you are seeing that this function which is here, we can split this using linearity property, whereby we can say this is the same as integral 4x to the power negative 3 dx plus integral, okay, to the minus x negative 2 dx minus integral of x squared dx. And then this is going to give us, so now when you integrate, what you do with your power here is this power, you add the 1, and then the answer you're going to get, you have to divide it. So we have going to have 4x, negative 3 plus 1, it's negative 2. So this negative 2 that we get here, we divide it to this side. So with this part we are done. We come to the second part where we have a negative. So now when you get x, and then the power negative 2 plus 1, the answer is negative 1. But remember, the answer that you get there, you also divide it here. Lastly, we have plus. So it's minus x squared. 2 plus 1 is 3. What we get there, we divide. Plus some constant, we don't know, some constant c. So this can easily be simplified as 2 into 4, it's 4 divided 2, it's 2. So it's negative 2. X to the power negative 2 is the same as 1 over x squared. So this is going to be over x squared. Then this negative and that negative cancels. So we have x, we have remained with negative x to the power negative 1, which is the same as 1 over x. So this will be, this and this gives us a positive. So this will be 1 over x. Last, this, it will just be the same x3 plus 3 plus c. So we have integrated. So that is the integral of the function that we are given. That is our integral, unless there's a question on that one.
You are remaining. Turajoga, okay, I'll teach you. Okay,
Breathe, yeah. Mike.
Innocent, don't
Question number 2.
Madam,
Yes.
Madam, when you study here, you are supposed to add a 1. Okay, I get.
You get it now, eh? It's great to hear that. So question number. So for the second part, question 1B, you are going to do it. The procedure is just the same. Then question number 2. Question number 2. I'll pick.
Madam,
Yes.
can you also slow?
So question number 2. Evaluate the following integrals.
Madam.
All right, guys. Now, if I told, let me pick question 2. Question 2B. Question 2B, which is integral. Evaluate the following integrals. Integral 1 over the cube root of x dx. So this is simply equals to integral 1 over cube root. So if you have this 3, this is just the same as x to the power 1. This is the root, so it is 1, and the power here is 1. So this is 1 over 3 like that. So this is equals to that. So now instead of me using this, I'll prefer using that which is there. So this will be x to the power 1 over 3 dx. Then this is equals to, this I'll take it up. It will be x. The moment I take it up there, it will be x to the power negative 1 over 3 dx. So this is equals to, next, we do the same. The inside part, negative 1 over 3 plus 1 over negative, what you are going to get there, 1 over 3 plus 1. Then we can just say plus some constant, c. 3, negative 1 plus 2. So we're going to have x to the power 2 over 3 over 2 over 3 plus c. So reduce or just do your apply some algebra there. You are going to find that this is just the same answer. 3x 2 over 3 over 2 plus c. Are we together on this one? Because what is happening here is this: you have x 2 over 3 divide 2 over 3. So when you are dividing this side, you just multiply. When you introduce multiplication there, you reciprocate. So I'm going to have 3 over 2. So this will be this multiplied by 3, 3x 2 over 3 over 2. So which is that thing that we wrote there. So that is the integral of that piece that is on the board. Unless there is a question. Unless there is a question. Silence means everything is cool. So maybe question number E. Question number 2E. Question number 2E is equals to the integral 5x plus 4 over cube root of x dx. Are you guys able to see what I've written?
Yes.
Okay, it's fine. I thought maybe you're not able to. So now this part which is here, what you're going to do now, we are going to chunk it. So we are going to chunk this. So this is going to give us integral of 5x divided by cube root of x dx plus 4 over cube root of x dx. So what this is just the same as that thing. And then next we just do some simplifications. So 5x over this part here, it is just the same as x to the power 1 over 3 plus 4 over x 1 over 3 dx. Using linearity property, I'll distribute the integral. So the integral 5x over x 1 over 3 dx plus integral 4 over x 1 over 3 dx. So this is, I can factor out 5 here. I factor out 5, and then here we're going to remain with x divided by this. So now when you are dividing those of indices, so when you are dividing, meaning that you subtract the powers. So this will give us x. The power for x there is 1 minus the power for x is 1 over 3 dx plus I'll factor out 4. We're going to the integral 1 over x negative 1 over 3 dx. So when you simplify this here, we have 5 integral x 1 minus 1 over 3, that's just 2 over 3, 2 over 3 dx plus 4. I'll take that on top as we did with the previous question. So we are going to say x. When I take it on top there, it won't have, so it's not a negative there. Sorry, it's not a negative. So when I take it on top, it will be negative 1 over 3 dx. Then I'll start x to the power 2 over 3. When you add the 1 to our power there, what are we going to get? So 2 is 2 over 3 plus 1. So we're going to have 5 over 3. So this will give us 5 over 3. What we get, we divide here. So we divide by 5 over 3 plus 4. So negative 1 over 3 plus 1. We're going to get 2 over 3. So 2 over 3, we do the same even here, 2 over 3, plus some constant c. Plus some constant c. Okay. And then this part which is here, when you divide, you're going to find that this 3 is going to be here. So 5, so 5 and 5 will cancel. So I'm just going to remain with 3 x to the power 5 over 3 plus this, it will be 3. There's x here. So 3 times 4, it's 12. So we just have a 12. 12 divided by these 2. So we just get a 6. 6x 2 over 3 plus c. So our integral for that part is 3x to the power 5 over 3 plus 6x 2 over 3 plus c. So that is the integral for that question there. Unless there is a question. Any question? Okay, there's a question.
Madam, repeat that again. You can just repeat
Okay,
that again.
this one on the YouTube, madam. Yes, I'll post it on YouTube. Okay. I repeat where?
From 5 to, and from 5, second to the last until at the end.
This part here. So now, let me just put it aside. We have 5x 5/3 divided by 5/3 like that. So this is division. So when you divide here, it will be 5x 5/3 divided by 5/3 like that. So when you divide here, you mean that when you introduce the multiplication here, you're going to reciprocate. So it will be 5x 5/3 times 3/5. So when you look at this, here we have 5 and that 5 cancels. So I'm just going to remain with 3 times x. 3x 5/3. That's how we remain with that. Is it clear now?
Yes, madam.
You're welcome. So for these other questions that are remaining, the procedure is just the same. The procedure is just the same. So we can just look at I and J. And then let's look at I and J. So I, we have integral of x squared root of x dx. So when you look at that, it is just the same as integral x squared root x is just the same as x to the power 1/2 dx. So when you are multiplying, indices that have the same base, we add the powers. So when you add the powers here, what are we going to get? So it is 2 plus 1/2. So integral of x, 2 plus 1/2 to give us 5/2. 5/2 dx. So this is equals to x. When you integrate when you add plus 1 to 5/2, what are you going to get? 5/2 plus 1. So it will be 7/2. 2, 5 plus 2, 7/2. So this will give us 7/2. Remember what you get here, you also divide it plus some constant c. So this is just the same as 2x 7/2/7 plus c. That's the answer for that one.
Madam,
Yes.
what happened to those 2 x's? The ones after you said it's the same as x squared, x.
So now when you are
raised to the power
multiplying indices that have the same base, what do you do to the powers? When you have a times a, and then this is having a 2 power 2, and then that is having a power 3. So what is the answer then?
You add the powers.
A 2 plus 3, which is equals to a 5, isn't it? So the same thing that we did on that one, where we have x squared multiplied by x 1/2, which is equals to, this also do the same, it is x 2 plus 1/2. So it is x. So this piece here is 2. 2 divide 1, it is 2. 2 multiplied by 2, we are going to have a 4 plus this one. So we are going to get x to the power 5/2. So that's the 5/2 that we wrote there. So let's look at J. If I may pose a question. If I may pose a question, guys, what is the integral of what I've written on the board there? Let me put this, let me put two. So what is going to happen here is you're going to integrate, first of all, that thing that is outside there. So you integrate this to the x squared plus 1, negative 2 plus 1 over negative 2 plus 1. Then next, multiply by 1 over what you're going to integrate. Now you integrate. Now you're going to not integrate, you're going to differentiate now. You differentiate this. So here when you differentiate this, it will give us 2x. When you differentiate 1, it's a constant, it's 0. So the differential of this inside bracket is 2x. So the answer you're going to get when you are differentiating, remember we're multiplying it, but now when you are integrating, you're not going to multiply what we have differentiated. Instead, you are going to divide it. So we are going to divide what we have integrated here, which is 2x. So this will give us, you can say, plus some constant. So this will be x squared plus 1 negative 1 over negative 1 multiplied by 1 over 2x plus c, which is the same as just the negative x squared plus 1 negative 1 over 2x plus c, of which you can just rewrite this as 1 over 2x and then that plus c. So now if that is the case, then when you look at question number 2J, question number 2J, applying the same idea, applying the same knowledge on question number 2J, let's see what is going to happen. So we have integral of root of x plus 3, or down x3 dx. So that question that is there, what is going to happen is this, guys. We'll start with the square root. We know to say the square root is just the same as x plus 3 over x3. The square root is just 1 over 2, isn't it? The square root is just 1 over 2. So that's our square root. And then if that's our square root, now next we're going to chunk. We're going to chunk what we have there. So this will give us integral of x over x3 plus 3 over x3, 1 over 2 dx, like that. So now after we've done that, the next thing that we're going to do is this. You can simplify. This will give us 1 over x to the power 2. I'm sure you have seen. Here we have x over x to the power 3. So this x will cancel with one of the x's here. So I'm going to remain with 1 over x to the power 2, then plus 3 over x, 3, 1 over 2 dx. So for easy calculations, I can take this up. I can write it as x to the power negative 2, isn't it? Then this I can write it as 3 x to the power negative 3, 1 over 2 dx, like that. So now we start integrating now. So now when you have reached at this stage, when you integrate, look at the power first of all. So when you integrate that thing, it will be the whole thing x negative 2 plus 3x negative 3. Then 1 over 2 plus 1. So 1 over 2 plus 1, it will give us 3 over 2. So remember what you get here, you divide. So we're going to have 3 over 2 divide by 3 over 2. We're done with the first part. Now next we deal with what is inside the corner. So now we differentiate. Remember what I said, when we differentiate now what is inside it, we differentiate, but the answer you're going to get, you're not going to multiply, but you're going to divide the answer. So now let's first of all differentiate that distance. So when you differentiate this, we're going to have negative 2x, negative 2 minus 1. We are differentiating, not integrating. What is inside, we are differentiating, and the answer you're going to divide it. So this is negative 2x. Now negative 2 minus 1, it will give us negative 3. We move to the next part here. Negative 3 multiplied by 3, it's negative 9x. Negative 3 minus 1, it's minus 4. So now the differential of what is inside here is just this. But now when you get this, you have to divide it. So this will just be under this. So here I'm going to have negative 2x, negative 3, move this, minus 9x, the power negative 4. And then plus the constant, which is the answer. Yes, someone wanted to ask a question.
Yes, madam, I was just kind of asking where that one is coming from.
Where?
One is coming from.
Okay, so here you have
Here
x
you
and
have
x.
added the,
Here you have x, and then x to the power 3 here. So now when you give, you have this x over x to the power 3. It's x times x times x, isn't it? So x into x is 1, into this x is 1. So you're going to have 1 over, you remain with 2 of this. So it will be x squared. Is it clear? Is it clear what this
oh,
one is?
madam. No. There, I'm asking from that side where you've said that 1 over 2 plus 1.
Here.
Now that one.
Okay,
is written-
you have to
No.
show me the step. I'll start from here. Is this the step we're talking about?
Step 1.
Is this this
Two.
step?
Now the third step.
This step?
The third step.
This?
Yes. Now the power there, you've added 1.
When you are integrating, we add a 1. So now here we have 1 over 2 plus 1. We are going to have 3 over 2, which is this. But what you get, you have to divide it. We have divided it. It's here. This is the first step. Now the next step is what is inside here. We have to differentiate. After you differentiate your answer, you have to divide it, not multiplying. That's what we do that's what we do when we're integrating. So you divide, you differentiate this, the answer you're going to get, you divide. So we differentiated the core, and then that is the answer. That is there. So you can take these 2 on top, and then 3 multiplied by that part plus c. So that is the integral for that function which is there.
Madam,
Yeah.
why is this different from what we did in the other one? The other one, didn't we do 1 over, like the way you've put that thing, the inside part that you differentiated? In the other question we did 1 over what we differentiated. Now here we're not doing that.
Okay. In the other one we did just rub this.